Imagine holding a piece of a star in your hand, a fragment of the universe's ancient past, captured in a single dazzling crystal. This is more than just a stone. It's a fragment forged deep within the earth, where unimaginable forces shape the very building blocks of our world. This is the story of the diamond, a crystal born from immense pressure and searing heat, hidden away for billions of years beneath the surface, waiting for its moment to shine. Diamonds are more than beautiful stones, they are time capsules, messengers from the planet's mysterious depths, carrying secrets of Earth's earliest days. At their core, diamonds are pure carbon, the same element that forms all life, from the tiniest plant to the largest animal, and even the air we breathe. But under extraordinary conditions, deep beneath the crust, carbon atoms are forced together, transforming into a perfect, crystalline lattice of immense strength and clarity. Their journey to the surface is rare and violent, carried upward by explosive volcanic eruptions known as kimberlite pipes, nature's own express elevator from the mantle to the crust. These eruptions blast diamonds from the depths, scattering them across ancient landscapes and making each discovery a clue to Earth's dramatic and ever-changing history. When you look at a diamond, you see a story of cosmic origins and geological drama, a journey that began long before humans walked the Earth. Carbon atoms, once part of ancient stars, are squeezed and heated until they lock into a formation of unparalleled strength, creating a structure that is both beautiful and nearly indestructible. Their journey is a testament to the dynamic power of our planet, a reminder of the forces that continue to shape and reshape the world beneath our feet. A diamond is not just a sparkling gem, it's a story of transformation, endurance, and beauty, as old as the Earth itself, connecting us to the planet's distant past. Each one is a survivor, a witness to the colossal forces that shaped our world, and a symbol of resilience through the ages. The diamond's brilliance is a reminder of nature's power to create something truly extraordinary from the simplest of elements, a legacy of light, strength, and wonder. To discover a diamond's true birthplace, we must journey far beneath the surface, plunging deep into the mysterious realm of the Earth's mantle, where few forces can reach. Here, at depths of nearly 150 kilometers, pressure and temperature soar to unimaginable extremes, creating an environment unlike anywhere else on our planet. In this intense crucible, carbon atoms are slowly transformed into diamonds, a process that unfolds over billions of years, hidden from the world above. The oldest diamonds on Earth formed long before complex life even existed, when our planet was still young and wild. Carbon atoms, adrift in molten rock, are pressed and heated relentlessly until they bond into a perfect repeating pattern, the crystal lattice of a diamond. This transformation requires a delicate balance, too little pressure or too much heat, and the carbon remains graphite, never becoming a diamond. Only within the narrow diamond stability zone can diamonds form, a testament to nature's extraordinary precision and timing. Once created, these diamonds could remain locked away in the mantle for millions, even billions of years, hidden treasures of the deep earth. Their only escape is a violent, rapid volcanic eruption, a rare and dramatic event that brings them closer to the surface. If the ascent is too slow, diamonds revert to graphite. Only a fast, explosive journey preserves their unique structure and brilliance. Every diamond is a survivor of this fiery, perilous journey through the Earth's layers, shaped by both violence and time. Their existence proves that, for a fleeting moment in deep time, every condition was just right for their creation and escape. Each diamond is a relic of Earth's most dramatic processes, a sparkling testament to the planet's ancient, powerful forces. Why is a diamond so hard? What makes this gemstone not only beautiful, but also the toughest natural material on Earth? The secret lies deep within its atomic structure, where the arrangement of atoms creates extraordinary strength. Both diamond and graphite are made entirely of carbon atoms, yet their properties couldn't be more different. The key is how those atoms are arranged. In diamond, each carbon atom forms 4 strong covalent bonds with its neighbors, locking them into a rigid three-dimensional lattice that extends in all directions. This structure acts like a fortress. There are no weak points, no easy planes for atoms to slip past each other, making diamond incredibly hard. To scratch a diamond, you'd have to break countless powerful atomic bonds at once, a nearly impossible feat with ordinary tools. In contrast, graphite's carbon atoms are bonded in flat sheets which easily slide apart. This is why pencil marks are left behind so effortlessly. Diamond's atomic perfection not only gives it legendary hardness but also makes it transparent, allowing light to pass through almost undisturbed. Light travels through the tightly held electrons in the diamond, making pure diamonds appear clear and brilliant to our eyes. Its famous sparkle or fire comes from its unique ability to bend and split light into a rainbow of colors, enchanting anyone who sees it. This property, called high dispersion, is a direct result of diamond's remarkable atomic structure and is rare among natural materials. Both its hardness and its brilliance stem from the same source: perfect atomic order, achieved only under immense pressure and heat deep within the Earth. The diamond's structure is a masterpiece of nature's engineering, formed over millions of years. It's a cosmic dance of atoms, resulting in the hardest, most brilliant natural material known to humankind, a true wonder of the universe. Diamond is the hardest natural substance, but what does that mean? Hardness measures resistance to scratching, ranked by the Mohs scale. This scale, from 1, talc, to 10, diamond, shows diamond at the very top. A diamond can scratch all other minerals, but nothing can scratch it, except another diamond. The jump from corundum, 9, to diamond, 10, is huge. Diamond is about 4 times harder. This makes diamond the undisputed champion of natural hardness. Even tough materials like steel or quartz are easily scratched by diamond. That's why diamond-tipped tools cut through rock, metal, and concrete with ease. Gold, though precious, is soft, easily scratched and dented. Diamond's atomic structure gives it absolute superiority, not just a marginal edge. Its resilience seems almost supernatural, a triumph of simple elements arranged perfectly. The Mohs scale reminds us, diamond stands alone at the pinnacle of natural strength. It's a clear demonstration of nature's power to create the ultimate material. Diamonds aren't just for jewelry, their incredible hardness makes them vital industrial tools. Most diamonds mined are bort, not gem quality, and are used in factories and scientific labs worldwide. Diamond-tipped saws and grinders cut through the hardest materials, from granite to delicate silicon wafers. In medicine, diamond scalpels allow for precise, clean incisions that heal more quickly. Geologists use diamond drill bits to bore deep into the earth, and even space probes use diamond windows for protection. Diamonds are the silent partners of technology and exploration, working behind the scenes. They help build cities, advance science, and push the boundaries of human achievement every day. Their value lies not just in their sparkle, but in their service to human progress. Diamonds are the sharp edge of innovation, bridging nature's power and human ambition together. Every diamond is a time capsule, preserving secrets from Earth's deep past. As they form, diamonds trap tiny inclusions, pristine samples of the mantle. For scientists, these inclusions are priceless, revealing the chemistry and conditions of ancient Earth. Some inclusions contain water, hinting at vast hidden reservoirs deep within the planet. Others hold rare minerals from the lower mantle, telling stories of a dynamic, churning world. Diamonds can even contain carbon from ancient life, recycled through geological processes. The carbon in your diamond may have once been part of a living organism billions of years ago. By analyzing inclusions, scientists can date diamonds. Some are over 3.5 billion years old. Diamonds are silent witnesses to the rise of continents and the evolution of life. Each one is a library of geological history, a narrator of Earth's epic story. Why do diamonds captivate us? Their journey mirrors our own struggles and triumphs. They symbolize endurance, resilience, and the power to emerge beautiful from immense pressure. When we give a diamond, we offer a symbol of lasting love and commitment. Its brilliance connects us to the cosmos, reminding us that beauty can arise from darkness. Throughout history, diamonds have been revered as symbols of power and invincibility. Ancient cultures believed they were tears of the gods, or fragments of stars. Holding a diamond connects us to this ancient tradition and the mysteries of the earth. Its value is measured in history, symbolism, and the wonder it inspires. The diamond is nature's toughest treasure, a union of simplicity and complexity. It is a tool, a jewel, a window into the past, and a symbol for the future. In strength there is beauty, in endurance there is light,